Okay, so good evening. We'll start and let the others join in the meantime. So I'll be sharing the slides. Just let me know if you can see it or not. Can you see this? Okay, I hope the screen is visible to you. Okay, thank you. Okay, so welcome to yet another problem solving session of natural hazards. And we are going to discuss the week 7 lectures and we'll discuss few problems on that. So, are the slides moving? Okay, I think there is again some issue. Just wait a bit. Okay, I guess the presentation mode is posing some problems. So I'm really sorry for that. I don't know why it's happening again. Okay, so I'll continue in this manner and hopefully I'll be able to rectify it soon. So, as I said, in this week we will be discussing the landslides portion, which is your week 7 lectures. So, uh, where are you guys from? Like, are you familiar with these landslide events or have you seen it anything? No. Okay, so I guess we'll continue. Okay. So, what exactly is a landslide? So, first of all, before knowing what a landslide is, you need to understand what mass wasting is. So, it's a comprehensive term. Any kind of downslope movements of earth materials, we call it as mass wasting. So, that's a general term for any kind of movement. Let it be a small scale movement, let it be a large scale movement, we call it as mass wasting. So when you talk about landslide, that is a type of mass wasting, but in that there is a sudden and unpredictable movement of large quantities of material like rock and soil. So that is what you call as landslide. Okay. So this movement, whatever movement is happening, either let's say when you say broadly if it is mass wasting or if you specifically talk about landslide, That movement is due to gravity. So you know that gravity is always pulling things down. So if anything is on a slope, so let's say, um, yeah. So if this is a hill and this is the slope, and if you keep some material, let's say you are keeping a ball over here. So this ball will always experience this effect of gravity. Gravity will be pulling it down. So that this ball will have a tendency to roll down, right? So similarly, when any material, loose material is there on the slope and it is coming down and it is unstable, so then that can come down by the effect of gravity. Now this can be falling, that is like if you have rocks, they will fall down. It can be sliding, so it can be like a section just along a plane, it is cutting off and sliding down. Or it can be a flow where you have a lot of saturated loose material, like water is there, rock is there, soil is there, all kind of thing. Or it can be a combination of all these things. So it need not be just one of these, it can be a combination of all of these. So the parameters which trigger a landslide, any landslide, it will be triggered by the slope, whether it is higher or it is steeper, or the type of material which is resting on the slope. So ideally, like most of the time, this landslides are quite frequently observed in regions which has high slope. So slope should be very high and the type of material will be very loose. So if at all that material is consolidated, like it is very tightly bound with each other, then it will not come down very easily. But if that material is loose, because of say the type of material, or because it has a lot of water coming in, so in such situation a landslide can happen. So the parameters, principal parameters which trigger landslide are the slope and the type of material resting on the slope. So if you get a question in your examination like this, like what triggers a landslide, or what are the factors affecting or causing a landslide, then the first and foremost one is the slope, and the second one is the type of material which is resting on the slope. Then it is also influenced by both natural processes as well as anthropogenic processes. So anthropogenic is basically by humans. Okay, so when humans influence something, then you call it as anthropogenic activities. So it can landslide can be caused by natural situations like heavy rainfall and all those things, or by anthropogenic activity like people cutting down trees and or people maybe constructing something along the slope, thereby destabilizing it. So all those things. Then excess, that's what I was saying, excess rainfall, down cutting, all these things can trigger a landslide. So the controlling factors of a landslide, of any landslide, is the ability of that slope to resist movement of material, and that depends on the driving force pulling it down and the resisting force holding it up. So let's say you have a slope like this. I'm just diagrammatically I'm drawing. So this is a slope. Okay, so you have a slope over here. So and you have a block like this on this. So the ability of this slope to resist movement, that is, if you need this block to stay intact, it should not move down, then that will depend on a balance between the driving force which is pulling it down and the resisting force which is holding it up. Okay, so it is a kind of a balance between these two, the driving force pulling it down and the resisting force which is holding it up. So the driving force which is pulling it down is what we had already discussed, that is the gravity. Okay, so the driving force which pulls down the material is gravity, and the resisting force which keeps that material on the slope is the strength and friction of that is the material strength and friction which is holding it in place. So if material has sufficient strength to stay put, then it will stay there, and that is the resisting force. And if it doesn't, then it is going to slide down by the influence of the driving force which is the gravity. So I hope you're clear about this parameters till now. So anytime, like if you, I think you have a problem based on this also. That's why I'm explaining these things. So yeah. So the slope, angle, and load also plays a significant role. So the relationship between the two is a key factor in slope failure. So the slope angle and the load, that is the weight of that material, that is a very, there is a fine line between that. Appropriate slope angle should be there, and the load should also be appropriate. If that is not the case, then the material will come down. So the idea is that steeper the slope, like if you have, this is a gentle slope and this is a steep slope, okay? So you can see the difference, right? So this is gentle, very gentle, and this is a very steep slope. So steeper slope will lead to greater driving force. So what happens is, in this particular case, the driving force is much greater, and because of which what happens is, the any material you keep on this surface, that is going to slide down. So that is slope failure. When it comes down, you call it as failure. So slope failure. So that is one thing, okay? So the steeper the slope, greater driving force, and the slope will fail. Another parameter you have to keep in mind is the angle of repose. So this can be frequently used when you talk about any slopes. So the angle of repose, it is the steepest angle at which any loose material is stable. So that I have a video and a picture, I think, so it will be more clear to you. The idea is that if you have a material, you know, let's say we have three conditions, okay? So I'll just erase this and okay, so let's say one slope is very gentle, and then gradually that slope is increasing. Okay, so it's a bit more inclined. Then we have a steep slope. So here, as you go from right to left, the angle is increasing, like the slope is increasing. So what happens is, if you have a material on top of this, so when you're keeping it over here, it is not sliding down. And when you're keeping it over here, it is also not sliding down. But when you're keeping it over here, it is sliding down. Okay, if that is the situation, then we say this angle at which it is still not sliding down, that maximum angle at which it is not sliding down, that is the angle of repose. So different angles for different materials depending on grain size and angularity and moisture content. Now this angle of repose is not same for every material. It is different for different material. So some material angle of repose might be 30 degree. For some material the angle of repose might be 60 degrees. So it varies from material to material, because the materials, like their grain size might be different, angularity might be different, the moisture amount present in that material might be different. So in that situation, each material will have each its own angle of repose. So I hope that is clear. So I think I have, yeah. So if you take a look at this, this is what I was talking about. So you have wet sand over here, okay, and this is dry sand. So the rounded dry sand, so when you keep pouring this, okay, they're pouring it from a mug. So they're pouring the dry sand on the ground. And what you will notice is, I have a video in the upcoming slide, but I'm still talking about this. So what you can notice here is that this uh, cone of sand, it is always at a particular angle, that is, after a particular limit, that angle is not changing. Okay, so this is not varying. However, if you see the wet sand, it is almost near vertical, like almost 90 degree. However, this one, if you see, it is like close to 30 degrees. So it is kind of gentler, and this is kind of more vertical in nature. So that is what I was talking about. The moisture content plays a factor, the kind of material plays a factor, and the angularity, the size of grain, all those things will determine what will be the angle of repose. So once it crosses this angle of repose, the slope will fail. So this video shows you what I was trying to tell you. So before starting the video, you just have to notice one thing. So here if you see, you can see that this cone tip is at like say 2 meter, 2 centimeter I think. Yeah, this is 2 centimeter. Okay. So now I'm going to play the video. So you have to just notice what variation is happening and just tell me what you're observing. So they're putting this material on. So they are keeping on adding that dry sand, and you can notice a particular thing. So I just want you to observe that and just let me know what you're understanding from that. So can you tell me what you could observe from this? They kept on adding sand. Then like what did you observe from this video? Okay, so if you have observed it clearly, then you would have understood that like by the time yeah, okay. So if you observe it, I don't know why it is going back again. So if you had noticed it clearly, so then you would have understood that initially it started from here, okay? So at around 2 centimeter. Then towards the end, you can see it is going close to this around like 2.5 centimeter. But even then, when people they're keeping on adding the sand, but then that height is not increasing. Like it is always maintained at this 2.5 centimeter. So here that height is maintained because the angle is maintained. So the sand, a dry sand will always have an angle of repose of about 30 degree. So in order to maintain that 30 degree, that material is distributing in that fashion in such a way that whatever, like they are adding more and more sand, but then the height is not increasing beyond a particular measure. So that is what I was trying to convey with this video. So the next one you have to understand is the frictional resistance and cohesion. So I talked to you about the driving force, which is the gravity. Now this driving force is opposed by the resisting forces, which is the frictional resistance and the cohesion. Okay, so we were talking about the driving force in the previous slide. So these are the controlling factors. Okay, so the ability of a slope to resist movement of material depends on the driving force and the resisting force. So the driving force is gravity, and the resisting force is basically the frictional resistance and the cohesion. So frictional resistance is the friction or the material, material's friction with the surface, and the cohesion is the that innate property of that material. So how each grain of that material is behaving, like whether it is able to stick to each other or whether they are very loose. So that is also important. So the frictional resistance, it depends on the slope, angle and the load. So the frictional resistance, that will depend on at what slope it is staying and the load. Like if that, even if the slope is very gentle and like weight is different, then also that slope can fail. So slope failure always occurs when the driving force is much greater than the frictional resistance. So driving force is indicated by F. So when F is much greater than small f, which is the frictional force, so then slope failure occurs. Cohesion, as I said, it is the force which holds the soil grains together. So I hope that is clear to you. So a small amount of water, like if you have, you know, grains which are separated, let's say. If you remember in this diagram also you can see, right? So you have dry sand in which all the sand grains are separated and they are not very well held together. So they can come down very easily. However, wet sand, some water is there. So that will, what happens is in dry sand, the grains are like this. Okay, so they have some space between them and they are very loose. But when in case of the wet sand, what is happening is that space between grains that is taken by the water, whatever moisture is there. So the moisture will hold all these material together, unlike that material when it is in the dry state. So a small amount of water will provide the cohesion and hold grains together. So if you have water, then what it effectively means is that not too much of water, just the right amount of water if it is present, then cohesion will be there. So the resisting force will be a bit more. Excess water, what will happen is it will increase the water pressure and decrease the cohesion. If you remember in when I was teaching this earthquake part, so there was solifluction, right? So solifluction was a result of this thing. Excess water is coming, so pore water pressure increases and the cohesion decreases. So the same thing we are talking about over here. So the right amount of water is there, material will stay. But when the amount of water is more, then the material will dissociate and it comes down very easily. So water will ooze out of the surface in a fully saturated ground, indicating an increased chance of slope failure or landslide. So in such slopes, let's say a slope is mainly the reason is like when you have heavy rainfall. Okay, so initially the water will go into the soil or whatever material is there on the slope. There is no problem. But then there will come a point if the rain doesn't stop, then water gets over, very much saturated, and then the water will no longer go down, rather it will ooze out, it will come out. So that will kind of uh, break apart the entire slope material and it will fail, resulting in a slope failure or landslide. So this thing you have to keep in mind. Always the appropriate amount of water is fine, but when it is increasing, like when it is above that limit, then that slope will fail. So always these geologists or people who study such regions, they will always monitor what kind of material is there, how much load it can take. So anytime we are making a construction on such sites where which is possible site for landslide, then you have to take proper consultation in order to do any construction or make any land changes, like do some agricultural activities. So you have to be very careful. So the increase in driving force can be due to. So the driving force is what? The gravity. Okay, so you have to always keep in mind the driving force, which can be indicated as capital F, that is gravity, while the resisting force is the frictional resistance. Frictional resistance as well as cohesion. This thing you have to bear in mind. It might be useful for your exams, or not just for exams, just for your awareness purpose. So this is what is happening. You just see some news on landslide, so you also have some scientific idea what is happening over there. So the increase in driving force, which is the gravity, can be due to when the slope angle increases. So as I said, if slope is gentle, there will be some amount of resistance, but then if the slope is steep, it is very easy for the material to come down. So the slope angle will, like if it increases, then the driving force increases. If the load increases, so the slope has a limit to which it can tolerate a particular amount of load. So if that load increases, then also the slope will fail, or the driving force will be more. So the increase in load. Then the other thing is natural or anthropogenic processes. So that's what I was saying. Like if people distort that land by doing some construction or some kind of agricultural activities, then also some problems can happen. Then turbulent currents in river channels. Okay, so the if some river channel is there in the slope, most of the rivers that we know, it is coming from mountains, right? So if some turbulent turbulent is in the sense that very violent river currents are there, that can also drive the driving force. So that is uh, so the things which favor driving force are all these things, and resisting force decreases when the slope material saturate with water, and or in when you have a shaking during an earthquake. So in all these events you can expect a landslide. So landslide is most of the time it doesn't come on its own. It is always along with some other thing. So at times it can be during a heavy rainfall resulting in a flood, which results in a landslide, or at the time of an earthquake, which when the shaking induces results in a landslide. So most of the time, landslide is always accompanying some other events, but at times very isolated events, landslide happens on its own also, when the slope for a long period of time uh, it is becoming unstable, and then it will fail. So what exactly causes landslide? So you have the gravity, which I was talking to you about, that will influence the slope stability. So I'm just giving you a mathematical interpretation of this. Like we told the qualitative interpretations, but we know what mathematically it is indicating. So the gravity is influences the slope stability, and it is responsible for most mass movements, as I said. So if you have a very flat surface, that's what I have drawn over here. So you have a very flat surface, okay? So this is a flat surface. So the gravity is pulling it down. Effectively, there is no movement, okay? So no movement under the gravity influence. So gravity is G is equal to Gp, and the that is, I will tell you what Gp and Gt are. So G here is Gp, and Gt is the tangential gravity. Okay, so that is, this is the perpendicular one and this is the tangential one. So here it is 0. You will understand what Gp and Gt is in the next slide better. So I will show you there. So gravity can be resolved into two components on a slope. Okay, so that is the normal stress and the shear stress. So if you have something on a slope like this, so the if I draw it like this, I'll show you. So this block of material is over here. Okay, so effectively gravity is like this. But this gravity, since it is on a slope, it will have two components. Okay, so perpendicular to this, we have Gp, which is the normal stress, and tangential to it or along this one is the Gt, which is tangential to the slope, which is the shear stress. So this is the normal stress and this is the shear stress. So anytime we have anything on a slope or otherwise also, you have this. Now in that flat surface, we had a material which was, this is, okay, one second. So you have a flat surface, you have the material block on top of it. Gravity is pulling like this. So the perpendicular one is also along this G, and the tangential one, you don't have a slope, right? So the Gt will be 0. Now in this case, if you see, if Gp and Gt are equal, like GP is equal, GT is equal, then there will be effectively no slip. It will balance each other. However, if this GT is greater, then it will pull it down and slope failure or landslide will happen. Okay, so I hope you are understanding what I'm saying. I have a problem in the next slide, so maybe you will understand it better. You can also try solving this. So the question is, what will be F, that is the effective force, and N, that is F is the force parallel to the slope, which in the one which we discussed, that is the tangential one, or the shear one, and N is the perpendicular one or the normal stress part. So can you try solving this in both the cases? This is for a moderate slope of 30° and for a steep slope of 60°. Just try solving it once. I have actually, since it's not in the presentation mode, the hint is also already here. So you can just tell me how you have figured it out and then we can discuss. Sorry, I was just trying to rectify it. In this way, I think you can see. Did you try solving this? It is an easy one, but I think you had a similar. I don't know if you had a similar question in your assignment, but you just have to solve this equation that I've given. That is it. Okay, I think you might have done this, but anyway, I'm telling you. So here, how I have figured this out is we are asked to find. Oh, sorry. We are asked to find the F and the N. Okay, so F is the normal force or normal. No, not normal. The force parallel to the slope, and N is the force perpendicular to the slope. Okay, so and the weight you are given as 100. So in the first case, this is F which is parallel. So if you look at this, this is a right angle triangle, no? So when in that right angle triangle, you just have to do is this. If you are familiar with, I'm sure you might have done this in your mathematics class also. So all you have to do is L is the hypotenuse. So L, then this is the uh, opposite side by hypotenuse is sine 30. So accordingly, we'll write it as L sine 30. And N is along this part. So again, L cos 30. So similarly, here L sine 60 and L cos 60. where L is the load or weight. So here it is 100. So this sine 30 is 1 by 2, I think. Yeah, 1 by 2. So 100 into 1 by 2 is 50. So F is 50 Newton. Then N is L cos 30, that is root 3 by 2. So 100 into 50 uh, root 3, I think. Yeah, 50 root 3 Newton. So like that you have to find it out. I hope you're able to understand that. So the increasing slope angle, shear stress component will increase. Shear stress is the component which is parallel to the slope. So when the slope angle increases, this shear stress component will increase and the slope is more susceptible to failure. So slope is more susceptible to failure. Water saturated material will complicate the ideal scenario which I have been talking to you, and the pore water pressure will act against the normal stress, thereby reducing the effective normal stress. So in such cases slope failure can occur even on gentle slopes. So if water is there, even on gentle slope the material can come down. So these are the certain conditions when slope failure can happen. So if in your exam they are asking you like in what all scenarios the slope failure can happen, so you have to say that when the slope angle increases, so what happens when the slope angle increase? The shear stress component will increase and the slope is more susceptible to failure. Then if water is added, even on gentler slopes, slope failure can happen because the water will result in the pore water pressure acting against the normal stress. So this is how whenever you look at a content in your lecture, you have to think what kind of question you can frame from that. So that way you can prepare better for your examination. Otherwise also all these information are worthy knowing, uh, especially for us when we are staying in a region which is facing several uh, of these kinds of natural hazards. So the strength of the slope material. So we have the shear stress and the shear strength. So I was talking about the shear stress, and same we have a term known as shear strength. So shear stress is mainly dependent on the mass of the material, which we were discussing, and shear strength is on the cohesion. So shear stress, we have the slope angle determining what shear stress will be, while the shear strength is determined by the internal friction. Okay, so shear stress, we know that in if you have a material on the slope, it is coming down, and this is your shear stress component, and this is how you resolve it. So accordingly, if you plot it like this, so we'll get the shear stress as W sine theta. I hope you're getting it, how we are getting this equation. So shear stress is W sine theta, and W is basically weight is mass into the gravity, acceleration due to gravity. So here you have a little bit of mathematics coming in, but then it is simple also. It's not very complicated. It's very straightforward. So if the weight is equal to 500 kilogram and theta is 30 degree, so W is 500 into 9.8, that you first find that out, and then the shear stress one you will find it out. Similarly here, the shear strength which is given by the Coulomb-Terezaki equation, which I had talked about in the last class also. So that is given by the formula C plus sigma tan phi, where C is the cohesion, sigma is the normal stress, and phi is tan phi is the coefficient of internal friction. So you just try to remember these two equations when and always keep in mind if they are talking about shear stress or shear strength. So if in a question you have something related to the shear thing, just make sure if it is shear stress or if it is shear strength. So the factor of safety for a landslide, so that is used to evaluate the slope stability. The factor of safety is used to evaluate the slope stability. So you have different slopes in different regions. So you need to know how, if that region is safe to stay there or to do any kind of activities. So in order to do that, you need to know the factor of safety, and that evaluates the slope stability. So the ratio of resisting and driving force gives you the factor of safety. So the resisting force is the shear strength component, which is C plus sigma tan phi, and the driving force component is the shear stress part, which is the W is W sine theta part. Okay, so this is the W sine theta thing. So this is how you determine the factor of safety for a landslide. So when the factor of safety is greater than 1.3, you have a stable slope. When it is less than 1, you have an actively unstable slope. And if it is like between 1 to 1.3, it is conditionally unstable slope. So this range, it's good if you can remember it. So if factor of safety is more, that means the shear stress is more. So the driving force is more. Not the driving force, I think shear stress is a normal one, right? Huh. If that is more, then it can hold it together. But if it is factor of safety is less than 1, then this component is higher, and the slope will become unstable. And if it is between 1 and 1.3, it becomes conditionally unstable slope. So in this part, if like this shear stress equation, the Coulomb-Terezaki equation, and this factor of safety, if you can just keep it in mind, that would be helpful for you. The internal factors which affects the slope processes are, for in case of slope, you have steeper slope means it is more prone. I know I've been repeating this again and again, but you have to keep this in mind also. That's why. Now, the oversteepening can be due to natural erosion or human induced through excavation or a combination of both. So, what happens is at times you might have a gentle slope initially, but then due to natural erosion in the sense that wind can take some material away, water can take some material away. So, in that sense, natural erosion can happen, and also humans can carve that area. So anyway, when that all these things happen, this gentle slope can become more steeper. So that over steepening can be due to these factors, natural erosion or human induced excavation, or a combination of both. Now, when the angle of repose, that is which I was talking to you about, that is the angle up to which materials are stable on the slope. So, when it exceeds this angle of repose, materials will become unstable and it will collapse. So, the internal factors affecting slope processes are the slope and water. Water enhances the chances of loose overburden. Then you have lithology. Lithology is what kind of surface materials are there. So rocks are there. So the rocks which contain minerals like clay, mica, calcite, gypsum, etc., they are prone to weathering and thus prone to landslide. So if the rocks are more having more hard minerals, um, or minerals with higher strength, then that slope will withstand any kind of external factors. But if that rocks which are there on the slope, they contain minerals such as clay, mica, calcite, gypsum, and etc., then that region is prone to weathering. Then you have geological structures. So we had talked about these faults, fractures, all these things, right? So when you have such small scale structures on the slope, so along that the erosion can happen. So instability will happen and then slope will eventually fail. So these are internal factors. Like within that material, what all things contribute to the slope failure. External factors are the rain or people affecting it, all those things. Then you have the climate, which is the direct effect on weathering and erosion on slope material. The vegetation, which I was saying, like if you have thick vegetation on the slope, so what happens is the direct impact of rain will not be there. So you are having a slope like this, and you have a lot of trees. Okay, so you have a lot of trees. So even if it rains, first it is going to touch the tree leaves, all those things, and finally it will come down. So the water is not directly impacting the surface and loosening it, so that the trees will protect it. At the same time, such big trees, they will have very strong roots holding this material together. So either way, that presence of thick vegetation will support the entire slope. But in some scenario, what will happen is, if the slope has very loose material, then the thick vegetation will act as an overburden. So everything needs, there should be a balance. At times, if that thick vegetation is going to add extra weight, then that will result in the slip in these steep slopes. So such things also you have to monitor, like if that slope is capable of holding this much weight on top of it. Then human influence, these are the external factors. So human influence is the slope stability caused by undercutting along the slopes for roads and rails. So you might have seen, if you have visited any hilly areas, so you might have seen this, if this is the hill, so you will see such, winding roads in that hill. So in order to build those roads, people, they will have to undercut the slopes. So when they do it, they have to be very careful, because if they do not do it in the proper way, then it will affect the slope stability. Then vibrations, as I was saying, earthquakes, explosions, volcanic eruptions, all these things can trigger the landslide. If I'm going fast, please stop me. I'm just assuming that you're understanding what I'm saying. That's why I'm just going along with this. But if you have any query, or you want me to clear something, just stop me. So these earth movements. So now we know what all things will result in these movements. Now, what all kinds of movements are there, that also you need to know. Mass movements. Okay, so that is what we'll be discussing over here. So just give me a minute. Okay. So as you can see here, these earth movements or mass movements are generally classified based on the material type, the movement type, and the rate of movement. So what kind of material is present, how it is moving, and at how fast it is moving. So that will tell you the classification of the different types of mass movement. So first one is the earth flow. So earth flow, we have solifluction, creep, and rapid flows. So flow is basically a lot of material is there, something is flowing. Then you have landslides, which you might be more familiar with. So we have the debris slide or slump, we have the rock slide and the rock fall. Then we have the subsidence, which is basically plastic flow and collapse. So I'll in detail we'll discuss the ones that are discussed in the lectures, but these are broadly how the earth movements are classified. They are classified based on the material type, the movement time, and the rate of movement. So the first one is solifluction. Okay, so solifluction comes under the earth flow. So solifluction, it is basically the slow flow. So it is a flow. Okay, so it is the slow flow of saturated soil downslope, indicating no frozen ground is present in the moving layer. So this mostly it is common in glacial terrains during summer. So summertime, what happens is that this let's say there are a lot of soil present, and during winter, if any water is there, that water will freeze between the soils. Okay, that is during winter. But when summer comes, these will melt, so that movement can be initiated by thawing, is basically melting of that ice. So that will create excess pore pressure in the soil. So this, what will happen is that that ice will become water. So it will exert some pressure in that soil, and it will result in the slope movement. But this is a very slow movement. Like, you have to observe it over a long period of time to understand that that region has experienced some movement. So here you can see, right, these all these features, they are a part of the solifluction. So this depends on the relief of the slope, the depth of the thaw. Thaw is basically melting of that ice, and water content are significant factors in the solifluction rates. So as I had drawn over there in the previous file, if you see, these are looking like lobes, okay, LOBES. So that is what it is written over here. They move down in the form of lobes. Saturated soils have increased pore water pressure. That's what I was telling you, resulting in unstable conditions because of a lack of friction and cohesion. So when pore pressure increases, there will be no, that materials will not be able to stick to each other. So that cohesion will decrease, friction will decrease, and the material will flow. So this is actually a side profile of that lobe. So lobe is like this. So this is a side profile. This can occur on slope less than 1 degree, but it is more common on slope gradients between 5 degree and 20 degree. So unlike this big movement, this one can happen on gentler slopes also. Here the only factor is that water is creating some extra pressure, and because of which the material is moving down. But it is a very slow process. If more relief is present, more relief means more slope is there, then the soil saturation will decrease as the water will drain down the slope as runoff. So if the slope was a bit more, like initially if the slope is like this, and the condition in which the slope is more, then the water which is melted can come down and it will not induce any kind of pore water pressure. So in such cases, solifluction may not happen. But in cases where you have a gentle slope and you have a lot of ice which has been thawed, then solifluction can happen. Then comes soil creep. Okay, so soil creep comes under what? Again, it is a part of the earth flow. So the soil creep, it is the slow downslope movement of surface soils and weak rock. This is again a slow movement, a slow downslope movement of surface soil and weak rock. This is a near surface movement, so it's not especially dangerous. Like this will be barely visible, and it is happening very close to the surface. So effectively, it will not cause any damage. But as I said, over a period of time, you can see that movement. Movement rates decrease at greater depth. So as you go down, the movement will decrease. So major part of that movement will be close to the surface. So if you take a look at this diagram, so this diagram properly depicts what I was talking about. So these trees, if you see, Initially they were intact, like this. Okay, they were like straight like this, but then when soil creeped beneath it, then what happened is they bent. That is what has happened over here. So these trees along the California highway have been bent by soil creep, the downslope movement of the upper layers of soil or soft rocks. They originally grew upright, but they were tilted outward by the creep. It continued upward growth, produced the bending. That is what this is a real life example, and here you have a diagrammatic depiction of that. Even these layers you can see, right? So here you have a sedimentary layer near the ground surface. It bends their upturned ends downslope. So here also this was straight initially, but then because of soil creep it got bent. So the trees also bent, and here this sedimentary layers also bent. So here I have a video showing this, so I'll just play it. So that is regarding soil creep. Now we'll come to mud flows. Okay, so mud flows, as the name suggests, if you have mud or clay which is dominating that flowing mass, we call it as a mud flow. Okay, so the in the other case you might have a in soil creep and all, you can have sand grains, all those things, but in mud flows you largely have mud or clay which is very fine grained and which sticks to each other when you have water present. So this is mobilized by abundant water uh, in a slope. So when you have a lot of water in a slope, then this mud or clay will come out. So then that is how it is going to move. The cohesive bond is lost between the particles. So normally if there is appropriate amount of water, then the mud or clay material will just stick to each other, nothing more. But when the water is too much, then the pressure will increase, and even this mud or clay will also dissociate. So that cohesive bond is lost between these particles, and most of the time mud flows are triggered by the heavy or prolonged rainfall. Either the rainfall will be very heavy, or it might be both heavy and might be for a longer duration. Then the flow, yes, haha, yeah, ask me, huh? So no, your question is not clear to me. I think your voice was breaking. Can you ask me again? Hmm. Hmm. Not exactly, like what I'm saying is landslide is it can happen by several factors which we had discussed, right? So if you have a region with active fault, so what happens is not necessarily because active fault is there landslide will happen, but mainly because if an active fault is there, that will lead to a earthquake, right? The chance of earthquake is more. So when that earthquake happens, if you have an unstable slope present, then landslide will occur. It's not necessary that all earthquakes can trigger a landslide, but if you have an unstable slope, then that can trigger a landslide. Is that clear? Yeah, yeah. And yeah, see, like what I'm saying is that is there. One thing is this earthquake factor. Another thing is if that surface, let's say, if you have a slope like this and its lithology is having a lot of these small scale fault or joints, so then that region, if you have a lot of rainfall or something, water can go into this small cracks or fractures, whatever it is, and then that entire section can collapse. So in that sense also it is there, but the term that you are using, these active faults is mostly associated with earthquakes, and then indirectly earthquakes will result in the landslide. That is how it mostly happens. Hmm? Yes, yes. Ha ha. Yes. Hmm. Yes, yes. That you're that like what you're saying is correct only. But what I'm saying is, just because there is an active fault present doesn't mean that that area will experience a landslide. The landslide is because what, you have an unstable slope, and that unstable slope is triggered by the when there is a movement in these active faults, that will result in the earth like shaking, and that shaking will result in the collapse. So it is linked to the active faults and landslides are connected, but not very directly. They are indirectly connected, that's it. Like you're right only, but this is how it is related. Okay, I hope that was clear. So, yeah. So as I was saying, uh, this mud flows. So if mud or clay dominates the solids, that will result in the mud flow. So what is happening is that if you have a slope which is significantly consisting of these very fine grained material, mud or clay, whatever it is. So first, if there is say some amount of rainfall, this can hold it together because water will go and this will absorb it, so there is no problem. But when the rainfall continues, or if the intensity of rainfall is high, then what will happen is that the bond, that sticky nature will be lost. That is what they are referring to as cohesive bond. That will be lost, and what will happen is that there will be a colloidal, let's say a very liquidy material which will flow down. That is the mud flow. The flow will stop only when the sediment solidifies due to water seepage. Sediment will solidify when the water will seep and go away. So only at that time this flow will stop. This can occur on very low slope angles also. So it's not necessary that you have to have a steep slope. Even in very gentle slope also this can happen. And the lahar, if you remember, that is a type of mud flow which happens in the volcanic areas, volcanic regions. Okay, so that is regarding the mud flow. Now I'll tell you, like I'll show you a video which shows you how quickly these mud flows move and how dangerous they are in that sense. So if you just look at this, so this is a mud flow. So you can see how very fine material is there, but that water and a lot of these mud and clay is coming. So it seems like it has stopped, okay? But that is not the case. You can see what will happen. See? So it's accumulating. It's a very, very thick material. It's kind of like uh, this batter that you prepare to make this idli dosa or something. No? So that thick material is there. And it will only solidify when the water will go out of this material. See, this guy is running because it is still coming. That's what it is showing over there. So it has broken that fence also now. It is not extending very much, but as more and more material comes in, it is coming a bit further. So now it has even come out also. So that is how mud flows come. So that is another kind of mass movement. Then we have the rotational slides. So rotational slides are a kind of landslide. So it's a, and that is the most common landslide type. So in landslides itself, we have different kind of landslides. So rotational slides are the more common. The most of the time when this is the one that is happening, and they are already also referred to as slump. So there are different terms. So it can be rotational slides or it can be known as the slump. Here you have homogeneous, cohesive, soft materials. Nothing big, but everything is like soft and which is sticky. Such material will be there. And as gravity pulls the material straight down, the surface curves at the top. I think I have a figure that might be more clearer for you. It's basically if this is material is coming down, so this will be how it is, like there will be a curve at the top. The curvature of slip surface rotates the mass as it moves. That is why we call it as rotational slide. That entire mass will be rotated, and the lowest end we call it as the toe. So here on at the top we have the head, and at the bottom we have the toe. So I have a diagram so that will be clearer for you. So here if you see, you can see a curve is there at the top. This curve is there, and this part you call it as the head scarp, which is exposed over here, and this is the head, and here you have the toe. Scarp is basically this region which is exposed, this brown region. So this is the head scarp, and then again there was another part in this, so we call it as a minor scarp, and here you have the toe. This is the displaced material. So this is a, like the more normal kind of landslide that you see, like the most common one. So here a real life example is shown. This is the headscarf. So you have a house on top of it. Here, from here it has gone down. So the home was left hanging. If it had gone a bit more into it, then the house would have also collapsed. So here also you can see, right? So here is this is a cross section of the rotational slide or the slump. So you can see the head, a near vertical head over here and the toe over here. So you can see here how the slump is happening. So at times it can just come as a single block, but most of the time if the material is too heavy, so you'll have such minor slumps in between also. So these exposed brown regions, you call it as scarp. So that is regarding rotational slides. So material is rotating. Then you have translational slides. So in translational slides, it moves on a pre-existing weak surface which lie more or less parallel to the slope. So if this is the slope and it has a weak surface which is slightly parallel to the slope, so this entire section will just slide down. It will not, that curvature will not be there. It will just slide down. So, like old faults is present or fracture is present, like you were saying. But in the one you were talking about, that is the active fault. But what is given over here is the old fault, which is basically weak zones. Okay, so in such regions, presence of such regions can itself trigger translational slides. It is dangerous because they move faster and farther than the rotational slides. Rotational slides, because they have that curvature formation, So it will take some time. But translational slides, they just have to slide along that weak zone. So it is much faster and much more dangerous. So here you can see this is the homogeneous material. So this is a difference between the rotational slide and the translational slide. So here you have the homogeneous material and it is slumping in this manner. Okay. The diagram you can see. Here, the tree roots don't penetrate deep enough to hinder the movement. So it will just slide and move. But in this case, if you see, material slides down the slope over top of stronger surface. So here, this is the stronger surface, which is a rock, and then you have some soil. So that will slide through that, and some tree roots may penetrate deep enough to hinder the movement. So if the tree roots hinder that movement, it will not continue. It will just stop like this. But if not, it can just easily slide past. I hope that difference is clear to you. Rotational slide is there, translational slide is there. Then we have rock falls. So from the name itself, you can understand, right? Nothing is sliding, something is falling. So there is a huge difference between sliding and falling. So in rock falls that mostly occur in steep mountainous regions like I think in Himachal Pradesh or like very high terrains like steep mountain areas. You can mostly you can see these warnings that chances of rockfall is there. So the rockfall is that large masses of rock will separate from a steep slope or cliff to fall and break into smaller fragments and they will move down. That is about the uh, rock falls. And it is at least 40 degrees steep slope should be there. Only then it will fall down. Otherwise, it can just roll down. So if it has to fall, at least 40-degree or more slope should be there. Steep slope should be there, and this can be triggered by strong earthquakes. That's what I was saying, earthquakes can also trigger this. And slope undercutting, like if people are building roads along that area and they are undercutting the slope, they have to be very careful. If not, this will just fall down. Blasting during mining, etc. And talus slopes are the fan-shaped pile of rock fragments which banged up against the cliff base. So that this diagram, I think it might be a bit, I'll just try to zoom it and show. So this is that material which has come down and is kind of fan shaped. And this is known as talus slopes. So that is regarding rock falls. So we had discussed about soil effluxion, soil creep, landslide. Within landslide, we have discussed about rotational slide, translational slide, and now we are discussing about rock falls. So the next one is subsidence. So subsidence, you might have recently, if you have read the news and all, you might have learned about this Joshimat subsidence, right? So that is a real life thing which you can relate to this. So subsidence occurs when ground settles due to changes in fluid level underground. So earlier, if that ground was like this, because of the fluid level going down or some variation in the fluid level, it will just you know slump down or go down. This occurs across large regions and hence effects are less obvious. That is the thing. Like that effect will not be very evident as soon as it happens, because this happens over a large area. So that huge area you will not understand. But if you monitor it intricately in every area, then you can understand that that area has undergone subsidence. And this causes considerable damages also. Small faults causing some areas to drop more than others will damage houses and utilities. This can be caused by groundwater extraction, drainage of clay rich soils, subsurface solution activity in limestone terrains. So, these are some of the causes. So, what happens is if you have a region which is not very stable and people are just, there are too many wells or boreholes or something present there, and groundwater is extracted, so that change in water level will result in the subsidence. The another thing is drainage of the clay rich soil. If clay rich soil is there and you drain those soils, then also subsidence can happen. Subsurface solution activity in limestone terrain. Limestone is basically calcium carbonate. So that is very fragile, and like some solution activity like this limestone material is leached out and all those things. Then over a period of time, that region can collapse. So recently, uh, I don't know if in India it has been noticed, but uh, I don't know any example from India, but I have seen some figures, pictures on online, in which a road, uh, a straight road suddenly collapsed. So that was because the region beneath that road was a limestone terrain, and that because of the solution activity and all, it lost support, and that entire region collapsed. So that is another kind of subsidence. Then recently in Kerala, there was an incident. Although people have not been able to point it out very clearly, like what has happened. There was an incident in which a lady was washing her clothes outside her house, and then in place where she was standing, there was a hole, and she came out near a like in their neighbor's well or something. So that people are attributing to a phenomenon known as soil piping, but it is yet not established. So we cannot for sure say, but because of the instability in the soil, that happened. So such things can happen, and you should be aware of it. So the subsidence one incident, like one example is in the 1964 Alaskan earthquake. The clay bed sitting in the deeper portion, capped by gravel succession, got squeezed because of the excess that strong ground shaking. So what happened is excess removal of groundwater resulted in an increase in the area of unsaturated or vado zone above the water table, which effectively resulted in subsidence. So here you can see parts of the San Joaquin Valley, California. It settled almost 8 meters, like that is more than 25 feet in the 50 years between 1925 and 1977. So this was where the land was. Then in 1955 it came till here, and then in 1977 this is where the ground is. So that much subsidence has happened. So you can see, right? The scale is this man. So almost 25 feet variation is there. So we have to constantly monitor such sites and, you know, do take the regulations accordingly. So control and stabilization. So how can you control such incidents, landslide events? So first thing is slope flattening. Unload top material to attain a stable angle and decrease driving force. So that is if you have a steep slope, so kind of try to make it more gentler so that the material can stand properly and the driving force would be less. Then you have terrace type farming. So instead of just scooping out and just building a lot of agriculture in one region, you can just make a terrace kind of thing. So the slope has more stability. That is both material unloading and slope reduction both will happen. Material can be taken out, and at the same time slope will also reduce. Then surface drainage control. So control surface water flow. Like if too much of water is there, then the problem is that material will get saturated. So you have to um, manage that drainage in that slope in such a way that that water doesn't percolate so much, so that it becomes unstable and the material slides down or slumps down or whatever it is. So you have to construct small water pathways to drain out water as quickly as possible. You should not give it time to go down and saturate the soil. It should just come out as soon as it is uh, like slide going down the slope. Then subsurface drainage. So groundwater and precipitation contributes to mass movement. If groundwater, as I said, like if it is too high, then also it can just oversaturate and then eventually result in the mass movement. So you have to be very careful regarding that. So water causes reduction in shear strength and increased load. So installation of perforated pipes into horizontally drilled holes. So you have to create a drainage path in such a way that the water doesn't get saturated. Another thing is retaining walls on slopes with loose sediments. This you can see in most of the regions where which is has this rock fall or landslide frequented regions. So if you are going along that road, you can see some net kind of material. They will keep it along that surface, that slope surface, so that they are known as retaining walls. So they will ensure that the loose sediment doesn't fall on top of the road or people. The vegetative cover so exerts hydrological and mechanical controls on slope stability. It will reduce the subsoil moisture. So if vegetative cover is there, that plants will take in some water. So it can balance the water present in that soil, and it can at the same time hold the surface materials together. But keeping this in mind, you should also understand that if the vegetative cover is too much, then also the land can become unstable, so that optimum level should be maintained. Then another thing that you can do is constant watch on landslides using satellite data, drone photographs or GPS stations, and compare photographs taken at different time. So as I said, in for instance, in the case of subsidence, as such, since it happens over a huge area, so the problem is that you will not understand if that region has undergone subsidence. But using these drone photographs or satellite data, whatever it is, you can actually monitor this on a larger scale. So it is easier for you to understand what is happening and what all things you can do for that. Okay, so this brings us to the questions for today. So before that, do you have any question for me? Or any part which is not clear to you, you can ask me. Okay, so we'll go to the question. I will change the mode so that it is easier. Okay, so for the problems, the first one is the downward movement of slope material under the influence of dash is termed as mass movement or landslide. You don't have an, I'm not giving, yes, yes, you're right. So the answer is gravity. So the downward movement of slope material under the influence of gravity is termed as mass movement or landslide. So the next question, when the slope material gets water saturated, there is an increase in dash force. Which force increases? Okay. So the answer is not resisting force, the answer is driving force. Because resisting force, when water is saturated, then what you have to understand is the material will come down. So for the material to come down, which force will be more? The driving force will be more. Is that clear? Okay. So the drive, because resisting force will always hold the material on the surface, but the driving force will enable it to move down the surface. So that is only thing you have to keep in mind is these two things. The component of force of gravity acting tangentially to the surface is known as. So you have to remember the components which I had resolved it. Gravity into two components. So which component acts tangentially to the surface? Okay, not strength, but shear stress. Okay, so shear strength is a property of that related to the cohesion, while shear stress is the force of gravity acting tangentially to the surface. That's why I was saying be very careful when you use the stress and strength term. Shear stress is that component, while shear strength is a property related to the cohesion. So you have to be very careful while using that. So the next question is, the reason behind tilting of the leaning tower of Pisa is A. Underground mining, B. Accelerated water withdrawn, C. Extraction of crude oil, D. Weak basal construction. So you might be familiar with this, no? Okay, yeah. So that answer is accelerated water withdrawal. So the Star of Pisa was not constructed deliberately as a leaning tower, but later on it became a leaning tower because of this particular reason. That is the accelerated water withdrawal. The next question is, in a rotational slide, the sediments slip on the dash plane suddenly in the form slumps, and thus it is termed as rotational slide. So, in what plane does this sediment slip? You just have to remember in what fashion it is coming down. Yes. So, the answer is curvilinear. So, curvilinear is basically that you know that scooped out structure that you could see on the head part. Okay, so a C kind of shape it has. So with that, the problems for this part I have just uh, finished. I'm not including your assignment problems today because the solutions are not yet out. I don't know if your deadline is done. So that's why I didn't include it today. But once they give it, then in the next class, maybe I can discuss if you have any queries on that. So, is there any other questions for me, or any part you want me to revise? Then I can make a note of it, and then we can discuss it in that extra hour, which I'll be taking on March 19th. Yes. Oh, talus. Okay, okay. I'll show you. One second. Okay, you were asking about this, no? So I'll. So this is basically. I'm really sorry. I'm not able to show this it in that slideshow manner. I don't know what happened. Okay. So talus is basically when this rockfall happens. Okay. So rockfall is what? You have a steep slope or a cliff for that matter, very steep. So the rock and whatever material is there, it is going to fall down. So when this falls, eventually what happens is at the base of that cliff, you will have this entire that rock fragments staying in the form of a fan. This is a side cross section. If you look in it from the front, you will see it in this fashion. So you will have a lot of this rock fragments piled at the bottom, fan shaped pile of rock fragments. This is known as talus or talus slopes. So that is what is written here. These slope accumulations or the talus slopes of volcanic rock blocks formed as rocks fell from the cliffs and rolled down slope. Uh, Coming to rest at their angle of repose along the Salmon River. So, if you remember, in the beginning of this lecture today, I had talked about the angle of repose. That is why these talus is always staying at a particular angle. It's not increasing, right? Like as more and more material comes, it will spread and it will maintain that angle of repose. So, this talus is basically whatever rock fragments are piled up at the bottom of the cliff during a rock fall. Is that clear? Okay. Uh, do you have any other questions, or I'm just asking, like, if you want anything from the previous class also, like if you want me to repeat any particular topic, just let me know so that I can note it down. And in the upcoming, not next week, I think on 19, that will be next to next week. So that day we will be having the last session and I can discuss any topic that you want me to. So just let me know today or at least by the next week so that we can I can plan accordingly and it will be helpful for you also. Do you have any more questions? If you don't have any further questions, then once again, I'll then we can stop today's discussion. Okay, thank you. So just let me know, okay? If not today, it's fine. But by next class, just let me know if you want me to discuss any topics or repeat any topics. Then we can do that. Okay, then we can end the meeting then if you don't have any further question. You can leave if it's done.